Let's say we're given a situation like this, and we're asked to find P1, P2, and let's just say P100, right? The 100th term in this recursive equation, right? Because this is recursive form. We want to kind of remind ourselves that these recursive forms of an equation are really just y equals mx plus b kind of in disguise. Because when we're given the recursive equation, we know that d is that extra bit that we add on each time to find the next term, i.e. it's the constant amount of change from one term to the next. Ergo, it's our constant rate of change, which is our slope. So we know m. And then when they tell us what P0 is, well, P0 means that was the starting amount we had before we started adding any increases, right? Well, that is our B, right? That's our y-intercept. A y-intercept is where we start before x, right? Before we add any m's, right? We have 0 m's, right? When x equals 0, we haven't added any d's. We haven't added any of those common differences. We haven't added in that rate of change yet. So we know that our P0, P sub 0, whatever you want to call it, equals B. And then, of course, we know that the D is the same thing as M, right? The difference is M. And so when we are given this type of equation, we can immediately rewrite it in terms of the y equals mx plus b form, right? So we can switch it over to something that we're a little bit more familiar working with rather than trying to do this whole recursive thing, knowing that we simply have our slope, right, is the amount of stuff that we're adding in each time. So we've got 125x, and then our starting amount, our 80, is our b. So now when they want us to find p of 1, that really just means find the equation when x equals 1. So we have y equals 125 times 1 plus 80, which is just 125 plus 80, which is simply 205. Done. Easy. Simple. We don't have to do this whole recursive thing. And then the same thing for p sub 2, right? They would lead you to believe that you first have to figure out what p sub 1 is, now it's 205, and then put it back into the recursive formula and go, okay, well now p2 is p1 plus 125, and so that's where we're just going to add another 80 to it, we're going to get 285. Just like if they wanted to do this the recursive way, we go, well, p1 is p1 minus 1, right? p0 plus 125, so it's going to be 80 plus 125, and there's the 80 plus 125, we get 205. And you might be thinking, well, that seems faster than doing all this. Well, yeah, maybe. And P2, could have been faster too. Now that you know P1, you know that it's just, you're adding another 80 to it. So it's 205 plus 80 is, 285. But you could also use the equation 125 times 2 plus 80, right? Which gets you 250 plus 80. And that equals 330. I think I misspoke back there and said, it's P2 plus P1 plus 80 when I'm sitting here staring at 125, right? We're just adding 125 each time. So we would take 215, add the 125 to it, and get 330. But then when they ask you to do something like find P100, do you really want to do this recursive formula another 98 times, right? Got to figure out P3, then P4, then P5, then P6, and get yourself all the way to P100. No, that would take you all day long. But once you realize that it's just this simple formula, then this just means, right, that x equals 100. We plug that in. We get y equals our slope of 125, right? That's our constant change, right? Our constant difference, as they call it, times 100 plus that initial starting amount of 80, right, our B, and that just gives us 12,500, right, plus 80, and that's simply 12580. So my whole point with this video is to remind you that we're learning nothing new when we're doing these recursive formulas and these explicit formulas. They're just a different way of describing the same old linear relationship that we should understand fairly easily as y equals mx plus b. Most people have seen y equals mx plus b a lot more frequently than they've seen the recursive or the explicit formulas. So if we can relate something new that might be a little odd to us back to something we already understand, that's how we learn new concepts. That's just how we learn. So this is a more effective way, I think, to kind of understand what's going on with these recursive formulas, is to always remind ourselves, oh yeah, this is just y equals mx plus b in a different form. They're giving me all the same information. They're just giving me the information in a different way, right? Instead of coming right out and saying, hey, the slope is 125, and by the way, b is 80. What's the equation of your straight line? And you go, duh, it's y equals 125x plus 80, because you told me what m and b are. They give it to you in this kind of roundabout way of, oh, here's this recursive formula where you're adding 125 each time, i.e., that's your rate of change, that's your slope, that's your m. Oh, and you started with an initial amount of 80, right? So you start with an initial amount when you haven't added in any of those extra bits. So that's when x equals 0. Oh yeah, that's the same thing as telling me what b is in my y equals mx plus b format. And then now I've got something that I know. I've got my good old slope-intercept form, and I can answer any question you give me at this point. Okay, so that's the way I would recommend tackling these types of questions.